finding traces of liquid water on a super Earth exoplanet. I'm Tonya Hall, and joining me is Dr. Angelos Tsiaras, postdoctoral researcher at University College London. Welcome, Dr. Tsiaras.
Thank you so much for having me.
Absolutely. So, what do you do in your role at UCL?
Well, simply speaking, I am analyzing data all day. So we're trying to observe exoplanet atmospheres. So exoplanets, planets beyond our solar system, far away, orbiting other stars, not our sun. And we are trying to look through their atmospheres and find out what molecules are there. We are doing this with the Hubble Space Telescope. This is because if you want to look at the atmosphere of a planet, it's not that easy to do it through an atmosphere of another planet, which is the Earth. That's why I want to go beyond the Earth's atmosphere into space.
What is planet K218b and why is it so big in the news right now?
Among the more than 4,000 exoplanets that we know right now, K218b is one of the few that is orbiting within what we call the habitable zone. In this area, it's not very close to the star, not very far away from the star, so it has the correct temperature to support liquid water. So this makes this planet exciting as many others, but what's even more exciting is that for this planet, we could actually go and observe it. If a planet is able to host liquid water, it doesn't mean that it has water. So if you think of Mars, for example, Mars is able to host liquid water, but it doesn't have any oceans, as we can see. So for this planet, for the first time, we found that it has indeed water in its atmosphere. Of course, it doesn't say that it has oceans in the surface, but if you have water and the correct temperature to support liquid water, then why not?
So the Hubble Space Telescope made the very first detection of water in the atmosphere of an exoplanet. So what scientific instruments on board Hubble were used and how was the data actually analyzed?
Well, just to mention, it's not the first time that we find water on an exoplanet. We have found for quite a few of them, but they were all gas giants. This one is not a gas giant. It's a smaller planet with a lot of chances of having a surface. Other planets were just pure gas, like Jupiter and Saturn. This one is smaller. It's what we call a super Earth. It's between Earth and Neptune. Now, what we do with it? Okay, so Hubble Space Telescope observes the planet as the planet is passing in front of the star. Like you can imagine of a fly going in front of a lamp, for example. Now, we didn't make these observations. Hubble was there to do this for us for a few years ago, not right now. So we took this data and we had to go through a lot of processing. So we have to clean this data. You can imagine of a very blurred photo that you want to turn it into a super high quality one. This is our main job. And from this super high quality picture, you want to calculate some numbers that say how the star is behaving while the planet is going in front of it. By measuring this behavior, and we're actually investigating the stellar light that is going through the planet's atmosphere. The planet's atmosphere is then leaving a trace into this light, the stellar light. We observe the stellar light and then we try to figure out by reverse engineering the problem, what molecules are there in the planet's atmosphere.
K218, the planet star, is about 110 light years from Earth. How do the instruments on Hubble observe an object so small at that distance and in such a narrow field of view?
Well, Hubble has looked very further away, what we call the Hubble Ultra Deep Field, billions of years away. So light is coming to us from very far away. The only thing we have to do is just stare at an object and the light will come to us. The only problem is then for how long you have to observe. So for this planet, I mean, in astronomical scales, 100 light years is not that far away. It's within our neighborhood. So we're observing the star, the light comes into our telescope, and this is how we get the observation. There's nothing to stop this light from coming to our telescope. Now, if this light is enough or not, that's another story. For this planet, the light was enough. For many others, it's not enough. So we should have been observing for weeks. For this planet, we didn't do the observation, but the planet was observed for, I think, about 60 hours. Yes, quite a long time, but enough to give us the signal that we want to get into the result. Of course, after all the analysis that I told you about.
How does K2 18 and 18b compare with our sun and Earth in terms of size, mass, and distance apart?
So the star is K218. K218b is the planet only. So K218, the star, is a small star, is a small, cool red star. It has a temperature of 3,500 Kelvin, much cooler than our sun, which is a bit less than 6,000 Kelvin. This means that this star is more active than our sun, so it emits more harmful radiation. Thankfully, this planet, K218b, is not very far away, not very close to the star. It orbits around it every 33 days. 1 year there is 1 month here. So this combination of the stellar temperature and the correct distance for the planet from the star, it gives the planet the correct temperature to support liquid water.
We all seem to be excited about the discovery of exoplanets. So what can we expect in the next few years? What will that hold for the study of exoplanets?
More exoplanets, for sure. The TESS spacecraft is now looking for more exoplanets, and it's finding lots of them. I think that in a few years we will have many more, and many more similar to K218b. So K218b is a planet with a mass 8 times the mass of the Earth and 2 times the radius, bigger than the Earth. It's not the same size. It's not an Earth-like planet. What we're looking at is the potential of habitability, so correct temperature and water for now. That's the only thing we can get. But in the future, more exoplanets like this and better telescopes, James Webb is coming in a few years, we will be able to see more molecules, not only water. So carbon-based molecules. These molecules are, of course, important and connected to life because we have a lot of carbon in our body, and life is based on carbon species. So that will be the next important step. First, this is the first one of many steps towards answering questions like, is the Earth unique, or are there other habitable planets out there? We still don't know. I have to say that this planet is not a habitable planet. We don't know if it is a habitable planet or not. We just have some hints, and we say that this is the best candidate for habitability that we know right now, but that's all, nothing more.
Dr. Angelos Tsiaras, postdoctoral researcher at University College London. If somebody wants to find out more about your work, maybe they're curious about exoplanets, how can they
You can
find
have a
you?
look at my website, www.angelostiaras.com.
Sounds great. Thanks again for joining us. And if you guys want to find more of my interviews, you can do that right here or go to tonyahall.net. Thanks for watching.